the elbow are oriented towards the wrist instead of shoulder to elbow to wrist, maybe?
Right. Okay. So I believe this is going to do what you're talking about. So the idea right now is the shoulder is going to orient to the wrist and the wrist is going to orient to the elbow, but it's not orienting in a straight line. So the process of taking the elbow out, orienting the shoulder in the correct direction. I mean that's I think that's what we're talking about, right? Getting everything
Yeah, I think
oriented.
that's what you did in the last video, but I also
Yes.
am not sure I understand the point of it.
Okay. Okay. I'm going to make this really extreme. So this is the front view. Sorry. Front view. Oh, that is the front view. So, his arm should be straight and it's way out of whack. From the top view, right, we would expect perhaps to see a little bit of bend in his elbow. That would be okay. But if we think of a triangle being formed between these 2 points. Sorry, I've got to figure out how to, I don't have a model here, so this may not make as much sense. I got to put honestly, the way I have these right now, if you can see me, not my screen capture, but me. If my character was modeled right now with not his arm straight, well, bent a little bit, with his shoulder turned up like this, then the rig would be right. But if his arm's modeled straight like this, but maybe there's the center of mass maybe rests a little bit higher because of the way the muscles or the volumes are modeled, but his arm should still be out straight. This would be completely wrong because we often use that trick where we follow the center of mass to kind of get our points, but they may not, right? This would be a straight line. Am I in the front view? Yeah, this is the front view. This is closer to that idea of having this straight line with the elbow pointed backwards towards the back of the mesh. If this were to come up, right, we're looking at the front of the model again. If this came up, and again, we're just kind of following the volumes of our mesh, and this happens to be where that volume falls. But his arm, you can't have an arm that this is the hinge joint. You can't have it also bend up at a completely different angle. If you can visualize that, I don't know whether or not you can visualize that. Our issue becomes trying to get these 3 joints in alignment. Right, so there can be bend in the hinge, but everything else really should be a straight line all the way down, or a straight orientation all the way down from the shoulder down to the wrist. I do need to put a model in here. That might make it easier to visualize this. Let me bring something in real quick. As our example, so let's just create, I think I'm just going to get rid of his clothing here. Let's just look at his left arm. So I'm just going to be really quick about this. We'll just select this edge loop and create a cluster. Same thing here at his elbow, just press G, and then at his wrist as well. Maybe there. Okay. Let's hide the geo, create some joints. So I'll just V-snap them into place. Let's look at the model again. The idea here with this model is he has, let's look from the top. Okay, his arm really is completely straight. We may put a little bit of bend in his elbow if we wanted to, but really he's got it straight out. So the elbow's not bent, wrists aren't bent. All he's done is rotated his shoulders straight up. So when we add our joints in here, really we want to visualize that the joints run from this front view, they run in a straight line from the shoulder down to the wrist. Okay, the shoulder might be oriented, if it's in an A pose, it might be like that. But the idea is still that they run in a straight line from shoulder down to wrist. if you were to look at them like here from the front view, for example. So let's go in and take a look at our actual joint orientations. Let's get rid of the clusters. I'll just hide the geo again, Alt-2 to toggle off the geo visibility. And let's go into skeleton, orient joint. Let's just show all of our local axes. Okay, and see what we've got. And again, for the sake of visualizing what's happening, let's really, I guess, make this a little more extreme. So let's take this joint. I'm just going to move it up a little bit so we can definitely see that I've got this. I'm not aligned. I don't have this straight continuous line between the shoulder and the wrist joint. Unless his elbow were turned way up, which it's not. That's not what we're doing with this model. So I need to get this elbow joint to come down kind of at an in-between point between those two joints. So what I'm going to do is just take the elbow joint out of the hierarchy altogether. And the wrist joint, I'm going to parent that directly to the shoulder. I guess I could name these so they make a little more sense. So shoulder joint, and elbow joint. Okay. My purpose in doing this is to set a baseline. What is the orientation I need so that the shoulder points exactly to the wrist? And that baseline will help me to place that elbow joint in the right place. So with that done, I can now use my orient joint tool and I'll orient the shoulder so that it points directly down to the wrist. So I'd want X pointing down the joint chain. I'm going to have Z, I believe in the negative Y is what I want. So that this is a positive rotation on Z, which it is. Okay, so I know right now that the X, that the shoulder joint is oriented in a perfectly straight line down towards the wrist. Okay, the wrist, let's go ahead and just zero out my joint orients. Okay, those aren't going to be, they probably are not the final orientation, but at least we can see that the two are in line with each other. And this should already be the case since we've oriented the shoulder to the wrist, but we should not have any values in translate X or translate Y or Z, nor should we have any rotation values. So just to make sure, I'm just going to select all of those fields and I'll just type in 0 and press enter. Let's try that one more time. That didn't seem to work. Okay. But I will have translate X values because that's saying I've moved this far away down that X axis from the parent, from the shoulder joint. So you should have translate X values. So we've determined we've got a straight line here. So we can see if we look at that elbow joint, we can see that it's too high. Vertically, it's too high. And then it's too far back towards the back of the model. But really, that could just be a little bit of bend in the elbow. That one is allowable. That one's okay. We can have a little bend in that axis. So, and this is kind of where it's like you determine if the arm's bent enough that you need that bend there, then leave it there. If it's not, I think it's the deformation actually looks a little bit better if you keep the arm completely straight. So if we look at where the this joint indication, this chain passes from the shoulder to the wrist, you can see the center of that passes kind of far forward. Right, I'm looking right here. That's a little more to the front than I'd like it to be, so that his elbow is going to bend a little funny. That's not where your elbow joint actually is. So I think I'm going to leave this joint more or less where it is as far as front to back, and leave a little bit of a bend in his arm. So I will have a little bit of joint orient Z value, but I should be able to get rid of everything else and essentially get this in line with the rest of the chain. So to do that, I'm going to now parent the elbow under the shoulder. Okay, remember the transformations now are the local transformations of the elbow are based on its relationship to the shoulder. So this is saying I've moved 29 units in X, negative 0.7 in Y, and negative 0.9 in Z away from the shoulder object, from that parent object. If I were to zero out both the Y and the Z, the Y, so I mean, if you look at the parent joint, Y is going to be kind of the forward and back, Z is going to be the up and down, and X is going to be the distance down that joint chain, right? And I can play around with these and verify that, right? X is how far away I'm moving down the joint chain. Y is forward and backwards, and Z is up and down. So again, you kind of look to the parent and see what the space of the parent is, and then that will help you to know in which direction you're going to move. So essentially I need to come down like this so that I'm in the exact same plane as the rest of the joint chain. So that's my Z axis. I'm just going to zero out Z. Okay. The Y axis, again, that's kind of my forward and backwards. If I zero that out, that's going to put me in the exact same line that I determined between the shoulder and the wrist. Right? Because now the only change I've made is this X that's determining how far down the chain that I move. So by getting rid of Y, it moves it forward so it's in the exact same plane, I guess. But bringing back the geo again, I feel like that's a little too far forward, so I'm just going to hit undo, and I'm going to move it back in the Y axis to, it was in the center, right about there. Okay, and if I'm only moving in that one Y axis, I'm in the right plane, I'm moving in the Y axis, that's okay, because when I reorient the shoulder to the elbow, and then the elbow to the wrist, all it's going to do is put a little bit of Z rotation on this joint. If I had this up or down off of that plane that the joint is in, or you think of it as a line that ties the shoulder and the wrist together, if I'm above or below that, I have issues. However, if I just move back, and again, you have to make sure you first have aligned your object with the parent. And you know what? I actually didn't. I made a little error here. Oh, no, I didn't. The translation is in regards to the parent, but I do have joint orient values. I should probably zero those out so I can ensure that that joint is oriented exactly the same as the parent. That didn't affect anything because the translation is in reference to the parent. But the point again is I can move back and forth in the Y axis once I'm oriented to the parent and parented to the shoulder. And that will come across as Z, joint orient Z value once I have this all oriented in the next step. Okay, so now if I unparent the wrist from the elbow or from the shoulder, I should be able to reorient the shoulder now directly to the elbow. So let's go ahead and hit this again. And you can see there was a little bit of rotation because I moved the elbow back. It rotates back just a little bit, so it's pointing to the elbow. And then I'll parent the wrist to the elbow, and then I can orient the elbow as well. And you can see that rotates forward just a little bit. Okay. And then, as always, we can just zero out any orients on the wrist. So let's take a peek here. On the shoulder joint, I'm going to have translation values because its parent is the world. It has to get up into this position. I'm also going to have X, Y, and Z orient values because I have to determine an orientation, an initial orientation. Okay. We look at the elbow. Okay, we should not have any translate YZ or rotate XYZ values. So just to make sure, I'm just going to zero those all out. Okay, if we look at the joint orient, we shouldn't have anything in there but joint orient Z values. And you can see I've got some really, really minuscule values. You know, at that point, I would actually just come in here and zero those out. If they're bigger values, when you zero those out, it's going to actually rotate the arm and it's going to move the position of the wrist, which we don't want. But those are small enough. It must have just been a slight miscalculation in where it placed the object. But that's close enough, I can just zero those out. Okay, and now when I look at my joints, again, this will have translate values and it will have joint orient values, but the wrist should only have a translate X and should only have a joint orient Z. And, or excuse me, the elbow. That's the elbow. The wrist should only have translate X values and nothing in joint orient that will match the same orientation as the elbow. See now that they are in a straight line from elbow to wrist when I look at it from the front. From the top, I do have a little bit of bend, but that's okay. We planned it that way. We planned on having a little bit of rotation there because that matched the model. And that's it as far as orientation goes. Does that help at all? Clarify anything, Sierra?
Yeah, yep, I saw what I was messing up when you went over it, so.
Okay, awesome. Okay, from there, if we were to build this IK system out, so skeleton, IK handle, I'm just gonna make sure I have my right settings. I'll reset that. Shoulder, wrist. Okay, so that's created my IK handle there. I'll just call this arm IK handle. Create a few controls really quick. So let's do a circle and I'll just group it while it's in place there at the origin. And I'll duplicate this 2 more times, one for the base, one for the pull vector control. Let's just name these really quick. So this would be the arm IK control. And its group. This would be the arm IK base control. And its group. And this would be the arm pull vector control. And its group. And then we need that offset group. So I'm just going to duplicate the pull vector control one time. I'll press down and delete to get rid of the shape node. Let's just give this a different name here. Arm pull vector offset group. And then we'll parent that pull vector control under the offset. So we orient with the pull vector control group. We push the control back into position using the offset group. And that leaves us with no values on the control. And let's get everything into place. So the arm IK control, we're just going to V-snap the group to the wrist. Okay. The base control, I'm going to V-snap to the shoulder. And the pull vector control, I'm going to match transformations to the elbow joint. So that will both position and orient it in the same plane as our IK system. Go ahead and make these controls a little easier to see. I'm just going to go into CVs. I'll just scale those up a little bit. So I'm adjusting the shape, not the transformation. Those are a little easier to see. I'm just going to rotate this guy 90 degrees. And we'll scale that up a little. So we know this one's a little different. I'll just scale in every other CV and create a little star guy. Okay, so now I can use that pull vector offset. Remember, I can push back in that y-axis. I can move it up or down the arm using the x-axis, but I can never move it on the z-axis, at least not before I create my pull vector constraint. Otherwise, it will cause a rotation in the arm when I set up the pull vector constraint. So again, using the offset group, let's just pull this back a little bit like so. And let's just set things up. The base control is going to point constrain the shoulder joint. Oh, there's a point constraint. The IK handle, we're going to parent directly under the IK control there at the wrist. And the pull vector control, we'll select that and shift select the IK handle and create a pull vector constraint. You should not see any shifting or rotating in the IK arm. When you do that, that's an indication that you've got everything lined up correctly. Okay, and those are all the parts we need. Let's go ahead and hide the IK handle. I can turn off all of my orients as well. Well, I'll leave them there in case we need them to visualize things. So, and then I would take these three control groups and let's group them up. We'll just say ARM IK master control group. So all of our controls are there. So, you know, if this were a full character, we would have a few other things going on here. Let's create another circle here. I'm going to scale it up, lay it down on the ground. So this would be like our transform. Maybe the grid would be helpful here. So that's our transform control. I can freeze that out really quick because that should have orientation with the world. And we'll go ahead and group it and call that transform, excuse me, control group. I probably would also have a cog, so I just duplicated that. Let's just make this shape a little smaller for the cog and rename some things really quick. Okay, so there's those two groups. You know, I'd probably have something, not probably, I'd have something up here for like the spine as well. We'd have it follow the spine. So let's just duplicate it one more time. Bring that up. This would be like the last joint in my spine. So I'll just call it spine control. And the group. Make that a little smaller too. Okay. And, you know, well, okay, let's see what I have in here already. So these I'd put in a skeleton group. All right, that would sit here under the asset node. These would all be somewhere under a controls group. So I'll just say controls. And now I'll spell it right. So all of these would be under here, and this would be under my asset node. And let's see, the transform is going to be like the topmost node. I'm just going to do this via hierarchy right now. Like, you know, we do most of these things via constraints using our broken FK hierarchy. But just for sake of time, I'm just going to put the cog under the transform, and the spine is going to be under the cog. And then the arm, the whole arm group is going to be part of the spine group. Okay, so I'm limiting part of what my system can do by just doing a hierarchy FK instead of, you know, having like the follow translates, rotates, or just using constraints and not relying on hierarchy at all. The whole organizational thing, but the principle is the same right now. So transform moves everything, right? Cog moves everything below it. Spine moves everything below it. So let's move the arm. So to Becky's question now, how do I get that pole vector to follow the foot, or in this case, to follow the arm or the hand? So if you remember, we created follow constraints, which allowed us to put multiple constraint targets onto one control, so you could switch back and forth to what you actually wanted it to follow. So to do that, I'm going to select all of the nodes that I want to act as a target, or a parent, I guess. And I'm going to start with the world node. Then I'll go to the transform, cog, spine, and lastly, I'll do the IK control itself. So these are typically the ones that I'll use when I'm working with an arm, right? Start from the biggest, the world, the transform and the cog, because we animate those a little bit differently. And then I'll go to the system it's connected to closest. So the arm, the closest system it's connected to is going to be that last spine joint. You don't want to go lower down the spine, because that would be weird if a lower spine joint moved. or it moved with the lower spine joint, but then when you tried to like rotate the whole shoulder girdle back, the arms didn't move in place, right? So you'd want the control that's closest in the hierarchy to act as the next target. And then if I'm looking at the pole vector right now, that's the one I'm working on. I'm also going to put the IK control as the last target. Okay. So those are my targets. And then the last thing I need to select is the parent group of the pole vector. So right there. It could also be the offset. It doesn't matter. I'll just do the pole vector control group. Okay, so that's the one I'm actually going to constrain. So we'll go up to constrain and we'll create a parent constraint. And you'll see in my parent constraint that all of those targets that I listed or that I selected are listed here as my individual targets. So starting with weight 0 or target 0, target what's a 0-based index. I've got the world, transform, cog, spine, and then that IK control of the arm. Right now, they're all sharing an equal portion of that constraint. So they all have, there's 5 of them, you divide 100 by 5, so they all have 20% influence right now. So you'll see as I move the IK control, for example, the pole vector is moving, but it's not following it completely. So we need to go in and create our set-driven keys to be able to turn those on and off. So on the pole vector itself, we're going to create a new attribute that will allow us to switch back and forth between the different targets. I'll just call this follow. And we're going to create an enum variable type that will allow us to give, basically give a name to different values is all it's doing. And we'll just list the different targets we created. So world, transform, spine, no, sorry, cog, spine, and IK control. Okay, those are the 5 targets. All this is, again, it's just giving a name to a value. And enum is just, it starts at 0 and counts up. 0, 1, 2, 3, 4. I'm going to have 4 values on this enum. But it's allowing us to label those numbers so it's easier to know what we're doing when we're animating. So hit OK, and you can see that that has added this enum with these different labels. But again, it's 0, 1, 2, 3, 4. That's what's really happening behind the scenes. And we've added these labels to those numbers. So from here, we need to go in and hook up this new attribute to our parent constraint targets. And we're going to do that via driven keys. So if I select this channel or any channel here, it doesn't matter, I can go up to edit and set driven key. And that will bring up this dialog here. So the control attribute here, that's going to be our driver. That's what's going to change the values. The values will be changed based on whatever this attribute is. So that's going to be our driver. So I need to, with that selected, I'm going to click load driver, and that will bring my pole vector control up into the driver. And then the driven is the object that we're going to change, or that is going to be changed based on whatever the driver does. And this can be one object, it can be multiple objects. It could be multiple attributes on one or multiple objects as well. We're just going to be working with that pole vector, or excuse me, that parent constraint and the targets. So we'll select that parent constraint. It has all of our targets on it. That's on the pole vector control group. And we're going to load that as the driven object. And then let's go and find our targets. So they're right down here at the bottom. And you see they're listed exactly the same. So ang W0, transform control W1. So you want to make sure you find those the target weight attributes. And those are going to be hooked into my pole vector follow attribute. Okay, so we need to tell the two that they're related. So on this control, I'm selecting this attribute as my driver. And on this constraint, I'm going to be selecting all of these attributes as the driven. And if you remember, there's a little bit of back and forth now. So you can select an item in these fields, in the driver or driven fields, and it will select the object in your scene. And I'm just going to step through this. So right now, follow is set to world. So when that is set to world, let's click on the parent constraint. I expect that the world constraint, this constraint to the world node, is going to be on, but everything else is going to be off. So I'll select all of my other weights and set those to 0. And now, again, I need to select what values I'm keying, right? So let's go back here, right? World is on, everything else is off. On the pull vector control, I've got it set to world. This is the object I want everything to follow. This is the target that should be followed. So now that I have my driver value and my driven values all set correctly, I'm going to, again, select that attribute in this driven key menu. So follow is going to affect all 5 of these attributes. And I'll hit key, right? And so what that did is it set a value that says when follow is at world, or when that's at 0, then all of these values on the parent constraint are going to be set to the values they're at right now. So the world constraint is on, everything else is turned off. And then we just step through it now. So now we'll go to transform. So when transform is on, we go to the parent constraint, we expect everything to be off except for the transform target. Okay, so my values are set the way I expect them to be. So again, follow attribute is selected as my driver, and all of these others are still selected as driven, so I'll just hit key. Okay, and we just work our way down through here. So there's cog, and then I want cog set to 1, and everything else is set to 0, key. Spine is my driven attribute now, so spine target is turned on, everything else is at 0. And the last one is IK control. So IK control is my driven attribute, so that means IK control is on, everything else is off, and we hit key. And then I always like to go into the graph editor, select that parent constraint, go into the graph editor. And you'll see the graph of what we just did. So if I click on that ANG target, that's the world node, it's showing me. So top to bottom is the value that's been set on this attribute. Left to right is the driven value. So in this case, it's the follow attribute. So when follow is set to 0, this ANG or the world node constraint, target constraint is set to 1. Okay, and you'll see this kind of follow down the row as a wave that's just moving from one side to the other. And if you'll remember, sometimes there are some interpolation errors that you'll switch from one to the other, and it'll, because of the way that the curve is smoothed, it will be really, really close to the value 1, but not quite. So your constraints won't work properly. So I like to select all of these attributes that we've keyed, select the keys, and just change the tangent type here to linear. And that will ensure that once the follow attribute is at 1, that the keyed attribute is also at 1 or 0. Right, so now your wave is going to look more like a set of just linear spikes. Okay, and that's it. So now when I have the arm pull vector control set to world, that's not going to follow anything. It's just sitting in place because that world node never moves. So it's just going to stay in its world place no matter what I do with this arm. Right, but now I can switch back and forth between some other options. So, right now it'll follow the transform, but it's not going to follow the cog. Right, it's not going to follow the spine, so on and so forth. Drill our way down. Typically, if you need the elbow to stay locked in place, you're going to go higher up the hierarchy as far as those target options are concerned. If you want the knee,
my problem. I've been looking at it from world and like, why doesn't it follow?
Oh, gotcha.
I did all this, and I was like, why isn't it following from world?
So yeah, if you want it to follow the IK control, you're just going to set it to that last option there, and it follows the IK control.
Okay, follow-up question for that, because I couldn't remember how to do it. How do you do the little line point that goes between the elbow and the control? I couldn't remember how to skin it, or what I need to do for skinning.
You're fine. So for skinning, we need joints. Okay, so we've got a joint already here at the elbow itself, so that's not a big deal, but we don't have a joint out here at the pull vector control. So we need one. So let's just create a new joint here. I'll just create joint. I'll just put it down here on the grid just because it won't let me really draw it in somewhere else. I'll just parent it to the pull vector control there, and let's just zero everything out. So that should go right to the center of that control. And then I can unparent it. It doesn't have to stay there. It can stay there. I think we put ours in a deformers group, if I remember right, just to keep the joints out of the control hierarchy. So we could call this the arm pull vector. I can't remember what we called them before. It doesn't really matter. I'll just call it skin joint. Okay, and let's put this in its own group for now. We'll just put it in a deformers group. Deformers. And in case we have additional deformers in here, let's just put this in a pull vector skin joint group. Because you'll have, for each of your limbs, you'll have one of these in here. And then I just need to make sure that I constrain it to this object. So we'll just do a parent. Well, I'll do a parent and a scale in case this object does scale up. Oh, I don't want to scale. I don't want this to possibly scale up the curve. I'll just do a parent constraint. Do that. Sorry. Let's think through this a little bit more. I'm just going to do a point constraint because really I just need the joint to follow wherever the control goes. I don't want to ever rotate it and have that curve possibly bend in between the 2 points. That would not be good. That would look really odd. So let's do a simple point constraint. And that'll just move the position. Well, if I actually create the constraint. Here we go. Control, joint. Control, joint, constraint, point. And then we create a curve. So we'll go to curve tools, CV curve. I'm going to pull up the options and I'm going to draw a linear curve. So I'll draw a straight line rather than a curved line. And I'll just V snap to the elbow and V snap to that new joint that I just created. Give it a name. So we'll call this whatever arm pull vector curve. Oh, actually, this is what we put in here before, didn't we? I think we just left this joint. Let's do this. There's so many ways we could do this. I'm just going to leave that joint parented under this control. We'll just hide it. I think that's what we did before. You can do it either way. And we'll call this the arm pull vector curve. Make sure that that's under our deformers, and that's going to be under our world node. So great, everything moves like it should. The curve is in place, it just needs to be skinned. So we'll select the elbow joint and the that new pull vector curve joint or skin joint and bind skin. Oh, I guess I ought to select the curve that I want to bind. So joint, then the curve, bind skin. Let's just make sure that it assigned the weights correctly. So I'm going to pull up the component editor, select my 2 CVs and make sure I'm on my smooth skins tab. And it looks like CV0, which is down here, is assigned 100% to the elbow joint, which is correct. And up here, CV1 is assigned 100% to the pull vector skin joint, which is great. That's what that should do as well. So should move around and follow. The only other thing is you don't really need to be able to select that. So we'll go into the attribute editor on the curve shape, object display, drawing overrides, and we're just going to turn on template mode. So that'll make it visible, but not selectable. And then the last thing is we really can just hide that joint. We don't need to see that anymore. So just tap that and press H. Right, and that's it.
Okay, so I just threw mine together like you did. And do you just do bind skin? Because when I move mine around, it's kind of bending. The line is bending around.
So I'm guessing you didn't create a linear curve like I did.
Thought I did.
So you should only have 2 CVs on that curve. That one at the elbow and
Oh,
one
yep,
to
you're
pull back your
right.
control.
Okay, that was all.
So yeah, if you just delete it, rebuild it, make sure it's linear. It could be not linear, but that degree of 3. You just have to take all of your verts. I'd kind of split it in half. Any extra verts, just V-snap them all to one side and V-snap the others all to the other side. And then make sure they're all skinned to one joint or the other is another option. That should work. Nah, it still might bend a little bit. Maybe not.
Yeah, I'll just
would bend
redo
a
the
little.
line. That's 2 seconds. So
Mm.
just the dumb little things that somehow mess you up.
Just forget along the way. I totally get it. So that good? We're good?
Yeah, those were my 2 big walls that I was hitting.
Okay. Great. 2 for 2. What else you got for me? Anyone else have issues or questions? Do you like my new studio that I totally is real? It's totally real.
Yes.
Thank you.
It's
great.
very fresh and airy.
Thank you. It is. It's really nice. The vegetation adds some nice green. Feels very alive in here now. Definitely not like I'm in a basement with a heater vent right over the top of me and no cold air return. And it definitely doesn't get really stuffy in here.
Clayton, I have a question.
Yes. Is it about my room?
Yes.
Oh, great. Okay, I will answer it now. Go ahead.
What do I have to do to get my hands on your creating control Windows script? Because I want it.
Depends what do you want to do with
Create some controls.
I'm willing to pitch in to whatever the price is.
I've been trying to figure that out for a while now too,
Please, Sensei.
and I haven't gotten very far.
Figuring out how to do it?
Yes. How to
So-
create a script like that to create
Yeah.
a window and controls and things.
I have no problem sharing my scripts, but I never want to deprive you of an opportunity to learn. So how do we meet halfway on this one? I'm open to propositions.
All right, Brandon and I are willing to do it for a small fee.
You're willing to do what? Take my script off my hands? Oh, that's so kind.
Oh dear.
We'll do it, you guys. We'll take one for the team.
I may as well just give you everything.
I'll take those lovely plants in the background as well.
Thank you. They're killing.
No, just kidding. But yes, I do want to make that script. Planning on it.
How about we do this? I'll take my script and cut out. I'll give you I'll give you the outline. I'll give you the script as it creates a circle. And the rest of other shapes, other forms, I'd like you to figure that part out. That part's easy. It really is easy.
Yeah.
But creating stars, creating boxes, creating whatever other crazy control you want. You build on what's there. Down the road, you figure it out. I'm happy to share the rest of it. But again, I don't want you to lose out on an opportunity to learn.
I think the main part of it that I have questions about is how you're getting your own pictures in, because I'm assuming that all of them you took your own pictures for, or like did like snipping tool or something.
Yep.
So getting those pictures, and then the only other part that I haven't messed around with, but I mean, I'm assuming it's just kind of a similar thing to like creating and setting attributes, is changing the colors of like NURBS curves.
Okay. Didn't we do that script last semester?
We never changed the. Did we change the color of them?
Change the override. You have to turn the.
We
change
changed the color, but it was Mel, and it's not translating very well to Python, and I couldn't figure out how to get it so that when you created the shape, it would just auto do it for whatever color you want, or how you could select a color and then have it create the shape.
Okay.
It's in a very rough Mel form.
That script seriously is like 4 lines. It's like stupid easy. You just take your selection and find the shape node that's attached to it, or shape nodes that are attached to it. You turn on the draw override.
Is that just an attribute?
Yeah, it's just an attribute on the shape.
Cool. So is it accessed the same way like you like we did earlier, where you have to actually do like a string, including like the name and then the attribute name all as a string?
Yes. So you guys can do this as I can, but enable override, right? There's my attribute. Whatever my shape is, dot enable override, and you set it to on, and then you have access to colors now. Oh, that one doesn't show. That's right. Well, if I turn on echo, I think I might if I turn on echo. Okay. This is one of those places where you do kind of have to guess, because it's showing that I changed the object slider, and there's a, oh no, there it is right there. Override color, and then it's taking all the rest of this is that specific object, that slider. It's finding the value of that slider. But it's just a color between 0 and 31. So between, like I said before, if I can just find the shape here, it's so simple. I'm just going to do it.
You just pick walk down, yeah?
You pick walk down, or I prefer to use the list relatives command because there may be more than one shape. And if there is, you want to change them all at once.
That makes sense.
So if you did, just find out what your selection is. That would be your first step, and assign that to a variable. Let's assume that you have more than one thing selected. Let's assume we have both of these objects selected. And I want to change both of their colors. So if that's the case, then I need to loop through. You know what? Let's start with one, and we'll make it bigger from there. We have one control. So we just want to say, we need to find all the shape nodes. So that's the list relatives command. Okay, the object that we're looking at right now is called, I'm going to change this instead of cells just to cell. So it's a single selection. Cell. Let's take a look at this really quick so I don't lose you on the documentation here. So we're looking at shape nodes. So that's really, I'll have to type in there, shapes equals true. Okay, and I need to assign that to a variable as well. So it's going to find any child shape nodes, and we'll assign it to this variable. And then assuming let's make the assumption right now there's only one, and then we'll come back and expand this. There's only one shape. So if there's only one shape, we're just going to enable the override on the shape and then set it to a specific color. So we'd say set adder. If you remember, that's if I click this on and off, you'll see that's what it's doing. A set adder, the shape node dot override enabled. So this is where I'm going to be using the name of the shape. It's stored in there. I need to concatenate it with this dot override enabled. So I'm going to put, I have to put a string in here. So the way I prefer to do it, if you remember, there's that syntax where I actually just write out a string, and anywhere where I want to take a value from a variable and put it in, I put a %s if it's a string. And later on down here, outside of this, we'd say %, which is an indicator that now I'm going to provide you the variables that I want you to add. I want you to substitute into the string here. And I would list the name of my attributes. So %s dot override enabled. Okay, and this actually was wrong. I need to have this here. That % comes right after the quotation marks or the single quotation marks. So again, %s is just a placeholder. And after the string, I put a %, and then I supply what information I want to actually go back and substitute inside of here. I can't just write this, unfortunately, because that's going to look for an object called shape, which doesn't exist. So instead, I'm taking the value of shape and I'm going to substitute it into here. Some of you guys might not like this syntax, and that's fine. You can still do this thing, shape plus override enabled. It's doing the exact same thing. I just hate seeing, this is simple enough, but when you start seeing more and more values that we're adding in here, I think it gets confusing. I think this is really easy to read. So that's going to set the adder override enabled, and I need to give it a value of 1, so comma 1. Okay, next, need to set adder again. In this case, it's the exact same object, so I'm going to type this the same, but in this case, we're changing the override color. Supply the value that I want to change. I should, by the way, if you only have one object you're going to concatenate into the string, you don't need parentheses, but if there are any more than one, you do a comma separated list inside of parentheses, and it'll just step from one to the next. So it's probably good practice to put parentheses there just so you remember. Okay, and in this case, we need to set this to a value somewhere between 0 and 31. Okay, so 15. So let's just see if this works. Okay. Oh, I need a parenthesis at the end of that. We'll run it. Okay, I did something wrong. Oh, I know what I forgot. Forgot to import my library. Let's run it one more time. Still doesn't like it. Invalid object named. Oh, okay. The ls command, you remember that returns a list. So I'm trying to feed a list into here, but I need the object inside of the list. So I'm just going to return index 0. That's the string contained within the list. So, and that error, by the way, hopefully you can see that the problem here, invalid object name. So there's no object named square bracket, right? Arm pull vector, or yeah, pull vector control shape. So I've just, it's wrong. It's returning a list instead of the string that I actually need. So let's try this one more time. Okay, got another error here. Same problem with my shapes. So I just want to return the first shape node. So I'm just going to put that only return index 0. Let's run it again. Okay, and you can see now that has been changed to that royal blue color. That's kind of hard to see. Let's change it to 18 and see if that's any better. There you go, it's that light blue shape. So right now this works great if I have one object selected and it only has one shape. So if we wanted to expand on this, it's just a couple different for loops. If we have multiple objects selected, rather than returning one index, we want to loop through any that are there. So here I'm going to change this to cells. Not that you have to change it, but there's a reason that I did that, and hopefully this will make sense here. So I don't want to return that one index. I want to do a loop here. I'm going to say for cell in cells. So that's going to loop through every item in my cells array, and each time it goes through, it's going to start with the first item, and it's going to substitute this cell variable with whatever the next item in the list is. Okay, and that's why I already named this one cell on purpose, knowing that I was going to loop through here. So I don't have to really change anything else. Okay, so it's going to loop through each object that I have selected. This needs to be part of the for loop as well. And it will change each color to 18, each object. So let's select these two and let's give it a shot. Okay, great. They're both light blue now. But obviously, if I have an object with multiple shapes, now you've combined shapes, this isn't going to work. It's only going to find the first shape node, and it's only going to make the change on that one shape node. So same thing here. We're going to do the exact same thing. Rather than just returning one shape, that first shape, we're going to loop through all of the shapes. So I'm going to call this shapes instead of shape, because list relatives is going to return a list of all of them, whether it's 1 or it's 5. And then I'm going to loop. So I'll say for shape in shapes. So again, that loops through all of our shapes in the list, and each time it goes through this for loop, it's going to substitute the next item in the list into this, or assign that value to our shape variable here within the for loop. Let's go ahead and step these in a little bit. And then it'll go through each one of the shapes, and it will override and set the color. So the last thing really is, do you want to have this set as a static number, or do you want to be able to change it? You probably want to be able to change it. So if this is in some kind of function, fine, and we'll just call this like change color. And we want to be able to provide a color, for example, which should be a number. Okay, so all we do now is when the function's called, we have to make sure we provide a number, and then we'll use that here and use that as our value to actually change the color. And you probably should have, oh, I just forgot what these are called. Oh, doc strings. At the beginning of your functions, you can put in these 3 quotes, or three single quotes or double quotes. If you remember, this is kind of a, when you click or when you type in like help and then the name of your function, it will display whatever is in this doc string between these quotes, double quotes. And you might just say, you know, variables, color, the type. You could say it should be an integer, and then tell what it does, or what it should be, a number between 0 and 31 to define the index color. Okay, so I'm going to load this all into memory really quick. Again, if I were now to type in help, change color, right? That tells me it's a variable, and it's a function. Right here it says it's a function, and it's telling me what I had in that doc string. So that could be helpful if, you know, you're running your script later on and you type in blue instead of a number, and it's going to say, yeah, sorry, that doesn't really work for me. So you can type in help and say, oh yeah, that's what it expects. If you wanted to dig in deeper in here, and you could put in like a translation. If you type in blue, that should equal number. You know, if color equals blue, then color equals 15, right? You could automatically assign specific colors or specific names to specific index colors if you wanted to, or you could just use the number straight up. So now I should be able to select these objects. Able to run the script, change color, and select a color. Let's go to 5. All right, those have all been reassigned to 5. Let's change it to 12. That's that rust color. Okay, it is a few more than 3 or 4 lines of code because I added some for loops, but it's not much more than that. 1, 2, 3, 4, 5. It's really only 6 lines of functional code. The rest is just setting up your function and importing your libraries, which you do all the time anyway. So hopefully you can see that's not terribly complex. It's pretty easy. I shouldn't say that. That might be a little bit challenging, but when you see the logic of it, hopefully you can say, oh yeah, that's not that big of a deal. Maybe a little confusing, but not that big of a deal. Not that hard to set up. I hope you're getting to a point where you can say that. Does that help, Steve?
Yeah, I have a question.
Yeah.
So the line 10, shapes equals cmds.list relatives.
Yeah.
So you're saying shapes equals true, but it doesn't give you every single shape under the selected things. Otherwise, you wouldn't do the for loop on 12. Yeah.
So okay. Yeah. So okay. If I have multiple objects selected, right, this first for loop is going to step through one object at a time.
Mm-hmm.
Right. That's what this for loop on 9 does. This is going to return all of the shapes for that one individual object that I have selected. So one object may have 4 shapes on it. It's
Okay.
just returning those 4 shapes. Then this line here is looping through each one of those 4 shapes and enabling the override and setting the color because they all have their own attributes. Each shape node has its own attributes.
I understand now. See, I did it a little bit different. I'm wondering, I think it'll work the same way, but I just did shapes plus equals list relatives in a for loop by itself. And then in a separate for loop that wasn't nested, then I did the set attributes.
Wait, say again, shapes plus equals.
Mm-hmm. So basically I just had line 9 and 10 in its own little section and just did plus equals for each one. And then line 12, 13, and 14 wasn't nested inside the for loop on line 9.
So you're just gathering all of the shapes on all of the objects.
I think that works the same.
And then you're setting them all at once. Yeah, that's fine too.
Cool.
Yeah, just another approach to it. Yeah, and then, going back to my UI, I've got this function sitting somewhere, right? And I've got a UI that, I just pull it up really quick. Oh, that's exactly what I needed. I messed a bunch of my scripts up recently, and so I still don't have a window to pull this up. Got to find the command for it. Come on, you're in here somewhere. There it is. I think. Well, that's not it either. That's it. I'm pretty sure this is where it is. Okay. Sorry, guys. Oh, I've got to build it. There we go. Anyway, so I've got these buttons down here where I've just made the button a swatch color. And when I click on it, it's running a function and supplying a particular index for that button. So all of these call the exact same function, right? They just provide a different value into the color argument there. So it just goes 0, 1, 2, 3, 4, 5, 6, and counts all the way up. That's all that's doing. So this one function works for all of those buttons, all those colors, just supplying different arguments. And oh, what I was going to do too is if I did have, let's say I had a few shapes in here. Actually, I can just build one. So this one here is a sphere. If we look at the shapes, it's really just 3 circles that have been rotated 90 degrees from each other and then combined under one node. So if I run this now, and let's just run this one too. So we have multiple selections, and we'll do this one too. Why not? And let's turn them all yellow. All right, same idea. It's going to drill down through all of the shape nodes for the selected objects and change the color on all of them, the override and the color on all of them.
How did you do the color swatches? I'm assuming those are all just pictures, yeah?
The color swatches, I'm gonna have to look at my script. It's been a little while.
On screen?
Maybe. Is it the window you're more interested in than the functionality of the script? Like how?
I mean, I think I can figure out how to make all the controls. I've already got a couple of them done. Specifically like the pin and I think a square or a cube rather. Gotcha. But yeah, I'm more so interested in the window itself.
Okay, let's look up here at the window. Well, that's not it. Where's my window? UI controls. What? Oh, I'm not even in the right one. That's why. Controls. There we go. I'll share this with you. I have no problem sharing this with you.
This is the best day of my life.
So, yes, so I did, looks like I did, I couldn't remember. I did just make a little PNG to save out the colors. I'm using, so it's an icon text button, so that allows you to make a button but attach an image to it. That's the same thing I'm using for these buttons as well. So I just used the snipping tool. I cut out the image. I took them into Photoshop and cropped them, but made sure that they were in relatively the same place. I set up a little template for me to make sure that they'd look right. Cut them all to the right size. And then I use these icon text buttons to apply them. And you can see here again, all I did, I've created every one of these. I've created an icon text button. I've told it what image to pull. This is what language it's supposed to be using when I click on the command, and then the command itself, I'm just using a lambda, and I've got a self.change color, and I'm just changing the number for each one of these. Okay, like we just talked about.
you're choosing the language that it uses?
So yeah, so the buttons sometimes they default to wanting to use Mel.
Oh.
So this STP, what does it stands for? I can't even remember what that stands for right now. But essentially, it's the language that it's going to translate this statement from.
Cool.
So
we
I
should probably
specified
include
just to
that
make
in
sure.
all our buttons, just in
Yeah.
case.
Yeah.
Okay, cool.
Yeah, I do as a backup. I've had it the other way, and the error that it gives you is not very clear. It just kind of says like, I can't understand that. And you're like, what are you talking about? It's right there. Yeah, I can type it in and it works fine. So yeah, I always provide that in my buttons.
Cool.
So the icons. So you're creating these little swatches in your documents, Maya version. No. Hold on. Let's see. It's in. I can't even remember. There's a folder for icons. Oh, there it is. So it's in your prefs folder. There's a folder for icons. Or not?
Could you just search the name of one of yours? Yeah. Could you just search color swatch 31.png?
I sure can. Good call. Let's just do it on my whole computer. I don't know where it is. Good call. Trying to think where else that might be hiding. Closer.
Maybe I just missed this, or you didn't say it. Is there a specific place you have to put these so that
Yes,
you can
there is.
access them? Okay.
Yeah, that's what I'm trying to find right now. Let's see here. My icon file location. It's one of those things you don't do it very often. You forget. Oh, I guess I could do this over here. My documents, Maya, shelves. Now. Oh, I found it. There we go. File location. Oh, you know what? This worked because I set up a Python path to this folder. So you can see these are all my icons here. And I specified specifically I want you to look in this folder for my icons. And truth be told, I can't even remember where I did that. That must be in my user setup. Bottom line is, yes, you do have to store it in a specific place, either the default or you can define via a user setup file. Yeah, that's not the right one. We've got some other crazy stuff happening in my file. Where I'm using something called modules, and it allows me to put everything off in a different place. Let's go back here and say my custom icon location. So this one for sure will work in your Maya folder like I looked at before. The documents, Maya, version number, prefs, icons, you can drop them into this folder. Like I said, I've defined kind of my working folder elsewhere. That's why I've got them. I've actually got them bundled with my scripts. And actually, if you guys, are you doing that? You're working out of a different folder. We talked about that at some point. You set up a Python path so that you can work out of a different folder and it will still pull your scripts into Maya. Does that sound familiar?
I remember you talking about it,
When
but Python wouldn't let me download it, so I don't know if I was able to set that up.
Python or PyCharm?
PyCharm, sorry.
Okay. Because were you on a Mac?
Yeah.
Okay. So what time is it? We probably don't have time to do this, but if you went into my sys.path, so you guys may remember that we did something like this. We had to import sys.path, and then we appended a path to our working folder.
Yeah, remember doing that.
Remember doing that? And so I've just got my icons folder in that working folder, and it pulls them in just fine from there. So like I said, either you can set it up that way, so you've added your working folder to the system path, or you can put them right into that, wherever that folder was. So documents, my 2020 prefs icons. You can stick them in that folder. And then in the code, you do not have to supply a path. You just give it the name of the file, and that it's going to look in the icons folder to find that picture. So I'll just share this file with you guys. It's not complete, okay? So it's taking, this is the window, but some of the scripts, like actually creating the control, it's actually pulling that from a different script, my controls script, to create the controls. But the rest of the structure here for how the window is built, short of the specific functions that are being run, that's all here. Even the framework for calling those functions, it's all here. Okay. And I think that feels like a good happy medium. You can get a really good idea of how a UI is created, a kind of more complicated UI than what we built. But I'm not giving you 100%. I'm giving you like 80% of the tool. Sound okay?
I'm really into this.
Okay.
I'm down with that.
Cool. So let's just open up this file really quick. There she is.
You're my
Hopefully.
hero, Clayton.
Did that post Well, you're my hero because you're going to go figure it out, and you're going to do better than me. Going to build on this and make things that are way better.
Wait,
than
was that the Windows script or the Controls script?
I sure hope it's the Windows script.
Is this one named Controls?
Yeah, that's the
It's
Windows
the
script.
Windows.
Okay.
It is. It is. They're both named Controls. This one I have sitting in a UI folder, but really it's a UI package, so it treats it as almost like a function of the UI object. So yes,
Cool.
I could see how that may be a little confusing, especially when I import controls up here. But that is actually importing a different script. So yeah,
Thank you.
If you have questions, yeah, you bet. If you have questions about it, just let me know.
Yeah, the next one that I want to get from you is, or the next script that we have to figure out is how you link everything to your GitHub in case your computer crashes and you just click a button and reload all your settings and stuff.
Oh yeah, my kind of my settings script.
Yeah, I want to do that one next.
Preferences script. Yeah, we can look at that next time.
Spicy.
We have so the rigs are due on
The 29th.
29th, which is Monday before class, before we meet, right? 29th, yeah. So yeah, we'll see. If we have time to talk about it in class, great. If not, you and I or whoever else wants to do it can chat offline.
2 down.
So okay.
Thanks, Clayton.
Yeah, you bet. We got like 4 minutes left if there's other questions. If not, get the heck out of here and enjoy your weekend, huh?
You too.
It's never a weekend. It's called homework time.
Homework time. Okay, enjoy your homework time. And relax a little bit. Please relax a little bit. Maybe go to bed one night, say before 3.
Hey, wait, I do have one more question, Clayton.
Okay.
How many cameras do you have?
Just 2.
I don't know how, but it seems like you have like 7. I feel like you're always swapping between them.
It's funny when I'm actually demoing, I can't see anybody, so I put you guys on the other monitor, but then every time I see myself, I'm not looking at you. So when I demo, I'm on this camera. When I'm talking to you, I'm on this one. That's all. I just switch between the 2.
That makes sense.
Pretty fancy, huh?
Too fancy.
The crazy thing about my setup here is my room actually rotates with the camera. So you'll notice that the perspective stays exactly the same. I've got my whole room on wheels, on casters. It's quite a process, but I do it for you guys.
Thanks. It makes it way more enjoyable.
Yeah. Oh yeah, I'm sure. Here's
Clayton,
a question.
your humility is astounding.
Thank you. Above and beyond. You guys hear all the running around and jumping in the floor above me? Or does this mic make it go away?
I don't think I've heard it today.
Yeah, I didn't hear anything today.
Okay. Yay!
Yeah, usually you can hear the thuds in the background.
Good. I'm glad I took a chance on this headset. And
yeah, we're semi-worried about your children.
You should be. They're
I'm
monsters.
more about his floors. With that many thuds, it must be like bowing by now.
You know, it's just an old house, and there's nothing here but floor joists and drywall, and the main thoroughfare is right over the top of me. And kids don't walk, they run and they jump and they slide and they roll. And this happens to be where my office is. So
darn those kids being
darn those kids. I know, it's the worst. So, here's a question I have for you guys. Do any of you guys do 3D printing? you have a printer at home?
I don't, but I help a buddy.
I do.
Okay, I'm getting one today, so I have no idea what I'm doing. So I may be asking some beginner amateur questions to some of you guys
That's
down the
exciting.
road. It's an Anycubic photon mono resin printer.
Okay, so it is a polyresin printer.
Mm-hmm.
Hey, I have a resin printer, so
Oh, okay,
we
awesome.
can do some troubleshooting.
Oh, that'd be great. I have no idea what to expect. It seems so easy, but so many people complain. So there must be more to it than I realize.
Yeah, and I'm still learning too, but yeah, let's
Cool.
do it.
All right, good to know. And Tyrell, you do printing.
What?
You don't have one, you said, but you do some with somebody.
I help a friend do it. So
Okay.
I help make models for him to get to him so that he can get them ready to print.
Okay, gotcha. Okay. Which resin printer did you have, Bean?
I have the QIDI Shadow 6.0. It's a knockoff, I think, of the of one of the Anycubics.
Okay.
Yeah, but it's pretty similar. It's pretty similar.
There's so many of them in that right there in that price range and performance point that are so similar. So.
Yep, absolutely.
Oh, cool. All righty, guys. Well, have a great homework days.
Thank you.
And
you too.
yeah, thank you. We'll see you on Monday.
Bye.
Yeah, we'll
Clay.
see ya.
Bye bye.
You bet. Bye-bye.